Okay, good morning, students. Today we will discuss about how to construct a decision tree. Okay, that problem. So this is the data set. They are usually, this is the most popular data set. Okay, play tennis. Whether we will play tennis or not, based on the different parameters. Four parameters we are using. That is outlook, temperature, humidity, and wind. So based on these parameter, whether we will play tennis or not. Okay, so here this is the target variable. Okay, that is play tennis. Yes, the conditions are yes or no. Okay, so based on this we need to construct a decision tree. Okay, so in previous class we have discussed about entropy and information gain. So here whenever, so entropy, it will provides the impurity in the data set. How much impurity is there in the data set? If the if the data set having uh, all are positive or all are negative, so at that time the entropy will be zero. It means there is no impurity in the data set. Okay, so then after that, if it is both are equal, positive and negative, that is yes or no, both are equal, so then that entropy will be 1. Okay, so here after that, when there is a difference between yes or no, so at that time what we are doing, that entropy will be varies from 0 to 1. Okay, so that one will be taken, we'll check the impurity of the data set. So then after that, information gain. Okay, so here information gain, it is used to, so we need to select from this four data set. Okay, four attributes, we need to select one of the attribute as a root. To get one of the data, one of the attribute as a root of the tree, so we need information gain. So information gain, it will predict the uncertainty in the data set. Okay, so it means it will gives the purity of the data set. So it means whenever you are dividing the data set, it will predict the purity of the data set. When the information gain is more from this, we will check for information gain for outlook, temperature, humidity, and wind. So which one is having more information gain, that one becomes the root of the tree. Okay, so first thing today we will discuss about how to calculate the entropy of a data set. Okay, so here entropy, it will tells the, okay, so entropy, it will tells about the impurity of the data set. So here we already discussed about uh, you know formula of the entropy. So here that entropy formula, so here in the data set, check it how many positives are there, how many negatives are there first. So based on this data set, okay, based on this target variable, how many positives are data set and how many negative data, that is how many rows are positive and how many rows are negative. So here when I calculate this, 9 rows are positive, check it. Okay, so then after that 5 rows are negative. So here check it, no, 1 2 3 4, and the last one, it will be fifth one, is last one is the no. It means 5 no's and 9 yes are there. 1 2 3 4 5 6 7 8 9. Okay, so 9 no's are there, 9 yes are there, and 5 no's are there. So it means the total set is 14. So in that, positive values are 9 and negative values are 5. Okay, so this is the positive values and negative values. How do you calculate entropy? The entropy will calculate minus proportionality of P. Okay, so minus proportionality of P, that is positive proportionality. So that is positive proportionality is nothing but number of positive divided by total number of values. Total number of values is nothing but a P plus N. P is 9, N is 5. Total is 14. That is positive values divided by positive plus negative. Okay, log 2 of positive divided by positive plus negative. Okay, there is proportionality of positive minus proportionality of negative. The proportionality of negative is nothing but N divided by P plus N. Total positive plus negative. Log 2 of N, proportionality of negative. Proportionality of negative is nothing but N divided by P plus N. Okay, so this is the formula. When you expand this formula, we will get this formula. That is, proportionality of positive is nothing but P divided by P plus N. Log 2 of P divided by P plus N minus proportionality of negative is nothing but N divided by P plus N. Log 2 of N divided by P plus N. Okay, then substitute the values of positive and negative values to this formula. Okay, so here P is how much? P is 9. Positive values are 9. 9 divided by P plus N, that is positive plus negative. Positive is 9 plus negative is 5. Okay, 9 plus 5, 14. Okay, log 2 of same thing, positive divided by positive plus negative. 9 divided by 9 plus 5. Like that, minus. Okay, so here negative divided by positive plus negative. So here negative is nothing but 5 plus divided by 9 plus 5, positive plus negative. Log 2 of 5 divided by 9 plus 5. Okay, so it will be, we are substituting the value. So then after that, when I calculate this one, 9 divided by 14, it will be 0.6428. Keep it minus, like the same minus, you keep it here, into log 2 of 9 divided by 14. So how do you calculate log 2 in calculator? Okay, so log 2 will be calculated in calculator. So here, so 9 divided by 14, that is log 2 of 9 divided by 14 is nothing but, okay, so here first that our 9 divided by 14 value is how much? 9 divided, 1 second, 9 divided by 14. Okay, so here 9 divided by 14 is nothing but, it will be 0.6428, it will come. So how do you calculate a log 2 of 0.6428? So it will be, so log 2, it means, so here in our calculator we don't have log 2, so here log 0.64 divided by log 2. Suppose if we have a log 10, log 2 of 10 or a log 2 of 5, so how do you calculate log 2 of 5? So that is, the base 2 is there, means that is log 5 divided by log 2, log 10 divided by log 2. Like that we need to calculate the values using calculator. Okay, suppose log 2 of 15, log 15 divided by log 2, log 2 of 20, that is log 20 divided by log 2. So like that we need to calculate the values for log 2. Okay, so when I calculate log 2 of 9 divided by 9 by 5, 9 plus 5, so I will get a value of minus 0.6375. Minus 5 divided by 14, it will be 0.3571 into, okay, this log 2 of 5 divided by 14. So I will get, that is log 5 divided by 14 is nothing but, 5 divided by 14 is nothing but 0.3571. So that is log 2 of 0.3, that is log 0.3571 divided by log 5. Okay, so here like that we need to calculate. So when I calculate log 2 value of this one, I will get minus 1.4855. Okay, so when I multiply these things, the negative into negative, it will be positive. When I multiply these two, I will get 0.4097 plus. So when I multiply these two things, I will get negative into negative, it will be positive, and when I multiply these things, I will get 0.5304. Okay, so now when I add this one, I will get the entropy of whole data set. Okay, the entropy of whole data set will be 0.9401. So this is the entropy of a whole data set. Okay, so this is the entropy of whole data set. Okay, so here 14 rows are there, 9 are positive and 5 are negative. The entropy is, it will be 0.9401. Okay, so this is the entropy of whole data set. Okay, so like that we will calculate the entropy of a data set. Okay, so when you calculate the entropy of a data set, we need to find the how many positives are there, how many negatives are there. Based on that, we will substitute the values. Okay, so we will substitute the values of positive and negative for this formula. We will get a final thing. Okay, so that is entropy of particular data set, 0.9401. Okay, so like that we will calculate the entropy of a data set. Okay, I have calculated the entropy of a data set. Okay, done. Now after that, like that we will calculate the impurity. So I need to select which attribute should becomes the root of the tree. So for that, what I need to do, I need to calculate the information gain. when I want to calculate the information gain, so for that we will have a formula. Okay, so here, this is the information gain. Okay, so this is the formula of information gain. So this, how do you calculate the information gain? Okay, so we'll come to that one. Okay, so this information gain is, I already told that it is the expected reduction in the entropy caused by partitioning the examples according to this attribute. So here that is nothing but a, so expected reduction. Okay, so in entropy, that is how much, entropy, that is impurity, will be reducted. Okay, so after the partition of the data set, that one we will call it as an information gain. We need to calculate the information gain. So how do you calculate the information gain? Information gain, okay, for a particular attribute. Okay, so the gain of whole data set for a particular attribute, it will be entropy of whole data set, whatever we have calculated just now. Okay, entropy of whole data set minus, okay, so summation of that values all the attributes. Suppose if we have a 4 attributes, outlook, temperature, humidity, so for that what we need to do, we need to calculate of all the entropy, which will be multiplied with positive or negative values of the particular attribute divided by whole data sets of positive and negative. Okay, so I will come to this one. How do you calculate this one? Okay, so this is the formula. Okay, okay, to calculate that one, so here we have a, okay, so here this is the, how do you calculate, okay, information gain. So the information gain will be calculated, 1 second. Okay, so first we will concentrate on entropy only. After that, when you're familiar with entropy, then we will move on to information gain. So here, so to calculate the information gain, so we need to find the which root becomes the root of the tree. So we need to identify that one. So here, whenever I want to identify that one, okay, so here we have a 4 attributes are outlook, temperature, humidity, and wind. So here we have 4 attributes: outlook, temperature, humidity, and wind. So from this I need to calculate, okay, so I need to calculate information gain of outlook, information gain of temperature, information gain of humidity, and information gain of wind. I need to calculate for all these 4 attributes. After that, I need to select which attribute having more information gain. So that one will be selected as the root of the tree. So for that, first I will concentrate on outlook. Now I will calculate the information gain of the outlook. Okay, so when I want to calculate the information gain of the outlook, so first I need to identify, so which are the different values are there for the outlook. So in that outlook we have sunny is there, overcast is there, rainy is there. Okay, 3 values are there. Sunny is there, overcast is there, rainy is there. Okay, 3 things I have: sunny, overcast, and rainy. So for all these things, I need to calculate, first I need to calculate entropy of all these values. Okay, so after that I will calculate the information gain. First I need to calculate the entropy of this sunny, overcast, and rainy. So okay, how do you calculate the entropy of the particular thing? Same thing, whatever we have calculated now. So for the whole data set, using those things, we need to calculate the entropy of whole data set. Okay, for a particular values. So here, when I calculate the entropy of a particular values for the outlook, so here first thing what you need to do, so we need to identify how many positives are there and how many negatives are there. Okay, so from this data set I have, okay, so from this data set I have taken, okay, from this data set I have listed here how many sunnies are positive and how many sunnies are negative. So here, when I take the values from that data set, so here 3 sunnies are negative and 2 sunnies are positive. Okay, that is positive is 2 and negative is 3. Okay, positive is 2 and negative is 3. So for that, what I need to do, I need to calculate the entropy of this particular data set. Okay, sunny data set. I need to calculate the entropy of the sunny data set. Same thing. Okay, so here I need to calculate the entropy of the data set. So here what we are doing, so here how do you calculate the entropy of a data set? For P, that is P divided by P plus N of old data set log 2 of sorry, not whole data set. So here, so how many positive and proportionality of positive log 2 of proportionality of positive minus proportionality of negative log 2 of proportionality of negative. Okay, so that is P of how many positives are there? 2 positives are 2 divided by how many positives are under negative? P plus N. P plus N is 2 plus 3, that is 5. Log 2 of positive is 2 divided by positive plus negative, it will be 5. Okay, 2 plus 3, 5 minus 3 divided by 5. Okay, minus 3 divided by 5, so it will be minus 3 divided by 5. Okay, so 3 is negative, N is negative, that is negative value is 3. 3 divided by positive plus negative, 2 plus 3. Okay, it will be 5. Log 2 of negative divided by positive plus negative. So negative is 3, positive plus negative is 3 plus 2 is 5. Okay, when I calculate this one, I will get minus 0.4. When I divide 2 by 5, log 2 of 2 by 5, it will be minus 1.321. Okay, so minus 3 divided by, it will be 0.6 star. Okay, log 2 of 3 by 5, that is 0.736. Okay, when I calculate this one, minus into minus, it will be plus, and when I multiply these two, I will get 0.5284. When I multiply these two, 0.6 into 0.736, it will be minus into minus, plus it will be 0.4416. Then when I add these two things, I will get an entropy of 0.971. Okay, so this is the entropy of outlook. So like that, entropy of not sorry, and this is not entropy of outlook, so it is entropy of sunny. Okay, so entropy of sunny, not outlook, sorry, so entropy of sunny. Okay, so like that, you need to calculate the entropy of overcast. Okay, so here like that, entropy of overcast and entropy of rainy you need to calculate. So here in this overcast, okay, from the data set, how many positives are there and how many negatives are there, you need to calculate. Okay, so here in this overcast, all are 1 2 3 4 4 positives are there. You can check it in this data set for overcast. Okay, so all are positive, that is overcast S, 1 is there, overcast S second. Then here when I count overcast, this is SS. Okay, so 1 2 3 4 overcast is there. All 4 overcasts are overcasts are positives. So when all are positive, what about entropy? It means when all are positive or all are negative, then the impurity of a data set is 0. Okay, so when all are positive, okay, when all are positive, the impurity will be 0. Okay, so that is entropy of overcast will be 0. Entropy of overcast will be 0. Okay, so entropy of sunny, it will be, okay, entropy of sunny will be 0.971 and entropy of overcast will be 0. So like that, you need to calculate the entropy of rainy. Okay, so you need to calculate entropy of rainy. So when I calculate entropy of rainy, so take the data sub data set from the main data set. So when I when I pick the rainy data set, so here rainy S is there, rainy S is there. First two rainies are S and next rain is no. Okay, so next rain is no, third one, so like that, and one more rain is there, yes, and fifth one rain is no. Okay, so same thing I have taken. So here Okay, so I have calculated. So here rainy yes, rainy yes, rainy no, rainy yes, and here one more rainy no. So it means positives are 3 and negatives are 2. So positives are 3 and negatives are there. The entropy of rainy is nothing but P divided by P plus N, that is 3 divided by P plus N, that is 3 plus 2, 5, log 2 of 3 divided by 5, that is positive divided by positive plus negative, that is 3 plus 2 is 5, minus 2 by 2 is nothing but a negative, negative divided by positive plus negative, that is 3 plus 2, log 2 of 2 by 5, 2 is negative and 5 is nothing but a 2 P plus N, that is 2 plus 3, that will be 5. So okay, so like that, so when I calculate this one, 3 divided by 5 is nothing but a 0.6 into, so minus 0.6 into 0. When I calculate log 2 of 3 by 5, it will be minus 0.7369 minus 0.4 into minus 1.321. So here negative, so here also minus 0.6, I missed this negative. Okay, so negative into negative, we will get a positive 0.442 plus 0. When I multiply these things, I will get 0.5284. So that entropy of rainy will be 0.9704. Okay, so now I have calculated the entropy of sunny, entropy of overcast, and entropy of rainy. Okay, so then, okay, I have calculated the impurity of these data sets. Then after that, I need to calculate average information gain. Okay, so I need to calculate the average information gain of outlook. So in that outlook, we have sunny, rainy, and overcast. 3 different values are there. So I have calculated 3 different values entropy. Then after that, I need to calculate the information gain, average information gain. So how do you calculate average information gain of a particular attribute outlook? So outlook contains 3 different values. Okay, this is the formula of to calculate the average information gain. So that is nothing but, so here we have 3 different values are there. For all these three different values, we already calculated entropy. Okay, so here how do you calculate? This is very easy. So average information gain is nothing but a positive of sunny. So here 3 values are there. Okay, sunny, overcast, and rainy. Okay, so and we have calculated the we have calculated the entropy of all those data sets. Now I need to calculate the average information gain. The formula will be positive sunny plus negative sunny divided by positive plus negative of old data set. Okay, so positive negative of old data set. See here P sunny and N sunny. How many positive sunny are there? 2. And how many negative sunny is there? 3. And how many positive and how many negatives are there for whole data set? It will be 9 plus 5. Okay, into entropy of sunny. We already calculated entropy of sunny is nothing but 0.971. Okay, so like that, positive overcast plus negative overcast divided by whole data set of positive plus negative. Okay, so whole data set of positive plus negative. Okay, so into entropy of overcast. We already calculated entropy of overcast. Positive of overcast is there. How much positive of overcast? It will be 4, and negative overcast, there is no negative values. So that's why value will be 0 divided by 14. Okay, 14 is nothing but a 9 plus whole data set, 9 plus 5. 9 plus 5 is nothing but a 14 plus 3. Okay, P of rainy plus N of rainy. So P plus N, that is P of positive of rainy is nothing but 3, and the negative of rainy it will be 2. Okay, so here and due to whole data set is P plus N is nothing but 9 plus 5. Okay, so 9 plus 5 is nothing but whole data set of P plus N, and into entropy of rainy will be 0.9704. Okay, so like that we need to calculate. Okay, so when I multiply these things, I will get 0.3464 plus. So when I multiply with 0, anything will be multiplied with 0 will be 0, and 0.347, 3465. So when I I will get the value of 0.693. This is average information gain for Outlook. Okay, this is average information gain for Outlook. Now, I need to calculate gain of the data set, gain of whole data set with the Outlook. Okay, so gain of whole data set with the Outlook is, that is entropy of whole data set, and this is average information gain of Outlook. Okay, so entropy of whole data set, that is first we calculated now the entropy of whole data set, that is 0.9401. Okay, so that one will be the entropy of whole data set, 0.9401. Okay, so minus average information gain of Outlook. So that average information of Outlook, just now we have calculated this one, 0.693. When I substitute this value, when I minus this this 0.693 from 0.941, I will get a final value 0.247. Okay, so this is the gain of the Outlook. This is the gain of the Outlook. This is the gain of the Outlook. Okay, so like that we need to calculate. Okay, so like that we need to calculate gain of other variables. Okay, other values. So here we have calculated the gain of Outlook. Like that we need to calculate the gain of temperature, gain of humidity, and gain of wind. Okay, so then after that, once we calculated temperature, gain of temperature, gain of humidity, and gain of wind. Okay, gain of temperature, gain of humidity, okay, and gain of wind. So then after that, from that we need to compare gain of all these four things. Which one is having gain? That one will becomes the root of the tree. Okay, so that one will becomes the root of the tree. Now I will give the task to calculate the gain of temperature for you. Okay, I will calculate. I will give the task to calculate the gain of temperature. To calculate the gain of temperature, what you need to do? You need to how many. So in this temperature, we have hot is there, mild is there, cool is there. Okay, hot, mild, cool. So how many hots are there? So for that you need to calculate the entropy of hot. Like that you need to calculate the entropy of mild, and like that you need to calculate the entropy of cool. After calculating all those things, you need to calculate the average information gain. After calculating the average information gain, you need to calculate the gain of temperature for whole data set. Okay, will you do this one? Okay, first calculate the temperature. Entropy of hot. How many hots are there? Okay, so will you calculate that one, students? I'll give you a simple task. So please reply. If you have any doubt, please ask. I will clarify the things. Okay, try it now. Please take the sheet of paper and calculator. Calculate entropy of gain of. Next, this is Outlook we have calculated. Like that, you need to calculate the entropy of gain of temperature. To calculate gain of temperature, so how many hot are there, how many mild are there, how many cool are there? So first that you need to calculate the entropy of hot, mild, and cool. Okay, so here when please do that one. I will wait for a minute. Okay, it will take 5 minutes. Okay, please calculate and tell me. First, how many hots are there, how many mild are there, and how many cool are there? Okay, so write the data set of those things, the different values of temperature, hot, mild, and cool. So then after that, you calculate the entropy of all those three. Okay. Please calculate and reply back. Please put answer in chat box. So in this data set, how many hots are there? How many mild are there? How many cool are there? So here, in this hot, we have two no values and two yes values. When both are equal, positive and negative are equal. So what is the value of entropy? That value of entropy will be 1. Yes or no? When both are no, all are positive and all are negative, at that time entropy value will be 0. When positive and when negative values both are equal, so at that time entropy value will be 1. Okay. So that one will be calculated. Entropy of hot is calculated. So like that, entropy of mild you need to calculate. So for that, how many positives are, how many negatives are there? Okay, P is 4 and N is 2. Positive are 4 for mild and negatives are 2. So then calculate the entropy by putting the values in the formula. That is P divided by P plus N log 2 of P divided by P plus N minus N divided by P plus N log 2 of N divided by P plus N. Okay, so here how many positives are there? Okay, 4 positive and total number of that is sum of positive and negative, that is 4 plus 2 is 6. Log 2 of 4 divided by 6 minus negative is 2, 2 divided by 4 plus 2, that is 6. Log 2 of 2 divided by 4 plus 2, that is 6. When I multiply these things, when I calculate these things, 4 divided by 6 is minus 0.666 into log 2 of 4 divided by 6 will be 0.5864 and minus 2 divided by 6 is nothing but 0.333. Okay, log 2 of 2 by 6 is nothing but minus 1.586. Okay, so when I multiply these things, I will get 3.0390. Okay, and plus when I multiply these two, I will get 0.5282. Okay, so that entropy of mild will be 0.9182. When I add these two things, I will get this one. So like that, calculate the entropy of cool. Okay, so how many positives are there and how many negatives are there for the cool? So here for positive, 3 values will be there, and the negative, okay, okay, and the negative, it will be 1. Then calculate the entropy of cool. P divided by P plus N log 2 of P divided by P plus N minus N divided by P plus N log 2 of N divided by P plus N. That is, positives are 3. 3 divided by P plus N is nothing but 3 plus 1 is 4. Log 2 of 3 divided by 4 minus negative is 1. 1 divided by 3 plus 1, that is 4. Log 2 of 1 by 4. When I calculate the values for those things, 3 divided by 4 is nothing but 0.75 into 3 by 4 is nothing but log 2 of 3 by 4 is nothing but minus 0.415. 1 divided by 4 is nothing but minus 0.25 into minus log 2 of 1 by 4 is nothing but minus 2. When I multiply these things, I will get 0.311 plus 0.5 when I multiply with these two. So when I add these things, I will get entropy of cool is nothing but 0.811. Okay, so we have calculated entropy of hot and entropy of mild and entropy of cool. Okay, so I have calculated entropy of all those things. Then after that, what I need to do? I need to calculate information gain. Okay, average information gain of temperature. Okay, so average information gain. So how do we calculate? So positive and negative values of hot divided by total number of positive and negative values of the whole data set into entropy of art. Like that, positive of mild value plus negative mild values divided by total values of positive and negative for whole data set. Like that, art is there, mild is there, then into entropy of mild. Okay, so plus then positive of cool plus negative of cool divided by positive and negative of whole data set into entropy of cool. When I add, that is positive of art is 2 and negative art is 2. It's a non. So in that first one is that is both positive and negatives are 2 2. That is both are equal. So that is 2 plus 2 and the whole data set P plus N whole data set is nothing but 9 plus 5, that is 14 into entropy of art is 1. Okay, so if both are positive and negatives are equal, then entropy value is 1. Okay, plus P mild plus N mild. Okay, so what is the P mild? P mild is positive mild is 4 plus negative mild is 2 divided by P plus N is nothing but a 14 into entropy of mild is 0.9180 plus like that the entropy of cool. Cool is nothing but P is 3 plus N is 1. Okay, and divided by total whole data set is 14 into here 0.811. Okay, so when I entropy of cool is nothing but, so here entropy of cool is nothing but 0.811. Okay, so that one I have written here 0.811. Okay, when I multiply these things, I will get a value of 0.2857 for this done, and 0.3935 for this one, and and 0.2317 for this one. Okay, when I add these things, I will get an average information gain of temperature is 0.911. Now I need to calculate the gain of for whole data set with the temperature. Okay, so how do you calculate the whole data set gain of whole data set? Whole gain of whole data set with the temperature, that is entropy of whole data set minus average information gain of temperature. So entropy of whole data set is nothing but 0.940 minus entropy of average information gain of temperature, that is 0.911. When I substitute when I subtract this one, I will get a gain of temperature is nothing but 0.29. Okay, so now I have calculated the gain of temperature. Okay, so two attributes I have calculated. See here. See here, I have calculated the gain of outlook and I have calculated the gain of temperature. So like that, you need to calculate the gain of humidity and gain of wind. Now your job is to calculate the gain of humidity. Okay, how do you calculate the gain of humidity? Okay, so to calculate gain of humidity, so first calculate the entropy of high, entropy of normal. Okay, so here we have two different values, entropy of high and entropy of value. So then after that, calculating the entropy of high and entropy of normal. So then after that, what we need to do, we need to calculate the average information gain. After that, calculating the average information gain, you need to calculate the gain of the humidity with the whole data set. That is the entropy of whole data set minus average information gain of the humidity. Like that, you need to calculate. When you come to wind here we have two things, strong and weak. Okay, so strong of entropy and strong of, okay, strong of entropy and strong of entropy of weak. So when you calculate those two things, then after that you need to calculate the average information gain of the wind. Then after calculating the average information gain, calculate the gain of wind with the whole data set. Okay, so like that you need to calculate. Okay, please try it. Uh, Gain of humidity and gain of wind, please try it. After that, we'll go for next step, calculate gain of humidity and gain of wind. Okay, please tell the answer. I will wait for five more minutes. Anyone calculated? Okay, do one thing. So I will take third hour class from 11:30. So within that, you need to complete the you know, try for anyhow you will get in half an hour time. So after the ACA class, okay, try for those two things. Okay, anyhow I will discuss in next class. Okay, at 11:30. Okay, at that time, if we, within half an hour, please try for those two things. Okay. uh, I will end the session now. Okay, so if you have any doubt, you can ask me. I will clarify the things. Okay, so we will meet you at 11:30. Okay, thank you very much. I will end the session now. You can leave the meeting. Pa. Okay, pa. Thank you very much.